Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we look at application development and management at scale. Cloudsoft is the sponsor for this week's episode of the New Stack Analysts. Cloudsoft makes application deployment possible across multiple cloud platforms with their open platform based on Apache Brooklyn. With Brooklyn, you can create an application blueprint and deploy it across a public or a private cloud. Brooklyn simplifies the modeling, deployment, and management of applications, enabling application migration, accelerating the development of cloud-first applications, and delivering policy-based application elasticity, scalability, and portability. Try it today at cloudsoftcorp.com. That's CLOUDSOFTCORP.com. Now on to the show. Hi, it's Alex Williams of the New Stack here for the New Stack Analyst Show from Las Vegas. We're here for IBM InterConnect. We're here in the Delano Hotel overlooking Las Vegas, the Luxor, and all that's beyond it. We're here to talk about what I think of really as distributed infrastructure and what it means today, in particular in context with a partnership that has been announced between Cloudsoft and a company InContinuum. And we are lucky today to have Duncan Johnston-Watt, the CEO of Cloudsoft. Hey, Duncan.
Hey, Alex. Hi.
We also have Phillip Hyde, the CEO of InContinuum. Hey, Phillip.
Good afternoon, Alex.
And we have Scott Hartzel, also of Cloudsoft. Good to have you guys.
Hi.
Hi, thanks.
Why don't we get started with you, Duncan? Cloudsoft is the sponsor of this episode of the New Stack Analysts. Please tell us about Cloudsoft and a little bit about the partnership that you have established with InContinuum.
Absolutely. So, Cloudsoft, one of the leading application management players. Everything we do is open source, so we've built the Cloudsoft application management platform on Apache Brooklyn, which is a project that we started a few years back and which is now a top-level Apache software foundation project. You'll find if you unpack AMP, a number of other components, moving parts inside it. There is a Cloud Foundry bridge, which we call the Cloudsoft Service Broker. And this is pertinent to this conversation, there's also the Cloudsoft Container Service, which is built on another open source project we curate called Clocker. And I know you've written about Clocker, been kind enough to write about that in the past. In terms of the conversation today and the work we've been doing with InContinuum, we've been very careful as we focus on application management to make sure that we can partner with and integrate with a wide range of cloud management platforms. And the InContinuum platform is particularly interesting to us because they do a lot of the heavy lifting, a lot of the stuff that really, quite frankly, we don't want to duplicate, let alone do ourselves, around the management of users, of access control, of billing and metering, and 20 other things, which really, if you're a customer or a consumer of cloud, is really, really important if you want to actually control the way in which the cloud is being used or consumed. So, by way of context, I think it's a nice partnership for us because we're able to leverage what InContinuum is doing and at the same time give them, I think, the upsell of really being able to offer blueprints like the Cloudsoft Container Service. And that's really what the announcement was about. It was saying, our first strike, if you will, is going to be to offer the container service. But now, rather than it just being an application blueprint, it becomes a fully automated, multi-tenant service.
We're also lucky to have Joab Jackson here with us today, and Joab is managing editor of the New Stack. Hey, Joab.
Hello.
Phillip, I wanted to ask you, there are a lot of terms out there. How do you guys define a cloud controller?
I like to define us as what Duncan said it himself a few moments ago, a cloud management platform. So we're a way to fully automate how you bring up services in a cloud. And that can be any service. It doesn't necessarily have to be a virtual machine or a container. It could also be a SaaS instance that's enabled through Cloud Controller, because we have all the plumbing that hangs underneath it. Cloud Controller connects to what you like to call multi-cloud, so we can talk to any on-premise hypervisor, any public cloud service, OpenStack environments, and we can use those resources to build a hybrid cloud that's fully automated and orchestrated. Okay, So that's the short explanation, but you use that resource to create 3 keywords: create, deploy, and manage the service. And Cloud Controller does that, our product Cloud Controller, in a multi-tier, multi-tenant model with full role-based access control and many other bells and whistles that I won't mention here in my introduction.
What's the role of containers in this type of environment, and how are you treating them differently than virtual machines?
So the Cloudsoft Container Service essentially lets you spin up a container or Docker-based cloud on any infrastructure. And so, if we were to do this ourselves, we integrate through Apache JClouds to many of the same underlying clouds, but without that layer of management around authentication and user management and access and so on. And so that's why we've elected to go through the InContinuum.
Yeah.
So it's not that we couldn't do it, but we'd rather do it in this context. And so, one of the value adds, and I think is a given now of being able to offer a container service, is it gives someone the ability to work with, for example, Docker, the Docker Swarm API, but have a fully managed cluster where we're looking after the cluster for them. We're making sure the cluster is right sized, so we're making sure that if more demand is placed on that cluster, more containers are requested, etc., that will grow or indeed shrink that cluster accordingly.
Okay. So it has that elasticity in it. What's the role then of the blueprints, per se?
So, maybe I can ask Scott to talk a little bit more about Clocker itself.
Sure. Clocker and the blueprints. The blueprints. The role of blueprints is to give you a place where you can manage the definition of your application as code. Not only the deployment parts, how this connects to this, and how the tiers interoperate, but also it's a place for you to codify your operational expertise. So you capture all of the things you normally ask your DevOps or operations teams to do with your application, the scaling, the HA, the failover, and you manage that as code when you deploy your application to a target environment. One of the target environments is Clocker or container environment. It's just simply another operational target for us that has strengths that I think work pretty well with what we did with InContinuum.
Yeah, and just picking up on that last point, the container service is a blueprint. Why? Because essentially what we're doing is we're requesting resources, we're installing Docker on those resources, we're rolling out a cluster, we're managing that cluster. It's software. The nice thing, and really the sort of, I guess, the party trick, if you will, although it's a bit more than that, is having instantiated the container service. At that point, we can just give it to somebody and they can interact with it just as they would Docker natively, or it can become, as Scott just said, a target in its own right. And that's the kind of, that's the Gestalt shift where you stand something up and then you can actually point at it. And not every blueprint is like that. I mean, many of our blueprints are rather more mundane, but nevertheless rich in their own way. For example, we've been working with, and I'm sure, by the way, Adam Ray, if he's listening to this, will kill me for saying mundane and basho in the same sentence. So I will retract that remark. I will strike that from the record. But you will no doubt leave it in because you're that kind of a guy. But when I say mundane, I mean essentially.
Mundane means consistent, though.
Well, let's do mundane computing then. Okay. But no, many of our blueprints, in fact, vast majority of our blueprints, stand up an application or a service, and then, exactly as Scott said, manage it for you, monitor it and manage it throughout its lifetime. And one of the cool demos we've been doing here at InterConnect, in fact, is showing how we can actually stand up Basho's React KV Enterprise Edition, which gives you this multi-cluster replication, and we can actually show that running in multiple locations. So Bluebots in San Jose, AWS, I think SoftLayer Seattle, just to make those guys feel at home.
Mm-hmm. Now, how does the combination of containers and your service and the service of both your companies bring us to commoditizing the clouds? In effect, making Azure pretty much on the same foot as AWS and giving the customers ability to move across according to their needs.
So I don't think containers in and of themselves do that, but I do think they are. Let's say they have utility value. So, and a lot of that utility is tied up with the fact that you can have Docker files or Docker images and you can reuse those. So if you take that idea and then you look at Docker Compose is, and again, I'm sure the Docker guys won't mind me saying so, it's a lightweight way of blueprinting an application, but it's somewhat specific. So what we'll do is we'll roll out an application where we'll use containers if that's appropriate for a particular tier. We might use VMs, we may even use bare metal. So what we're actually focused on is what's right for the application. What does the application really need? And then, and I know it's a loaded term, we are the, quote, honest broker that will then ensure that we get the right resources in the right context, be it containers, VMs, or whatever. And that, to bring it back around to InContinuum, is the nice thing there is that when we talk about locations, we typically think of a management endpoint in a cloud, AWS, US East 1 or whatever. They are in effect presenting a multi-location environment for us, so we can actually go through them, a multiplex through them, and get out to a wide variety of different backends, but using their sort of access controls and so on across that.
And
so
the cloud automation engine.
Yeah.
InContinuum Cloud Controller sees a container, for example, as another service object that's put into what we call the cloud automation engine, which is all the processes and workflows required to take resources from any location and deliver it as a managed service. For example, what do I mean? You can set up a distribution channel in your cloud. I want to deliver this to a certain group of users, maybe in a certain location, or I want to do one-tier distribution of this service to an end user, or two-tier distribution, or three-tier distribution even. That's all possible. So we see that service object as just another entity that's managed through our cloud automation engine.
Now, how is that programmed? Is this a declarative thing, or how do I set this up? Do you have a GUI, or how does that work?
We certainly have a GUI. We have an installer. You double-click on it. We're not offered as a service at this time. We do have the ability to create, for example, if you want to talk about the context of SoftLayer or Amazon or Azure, you can make an AMI or whatever the entity is, and you can have it preloaded. It's a server-based application, multi-tier architecture. You can have a separate server for your portal or our application services and our database. And you roll us out onto a specific server platform, and then you connect in what you call the multi-cloud locations. And from that basis, you build a service catalog of things you want to distribute as managed cloud services, amongst other things, a container that's been spun up by Cloudsoft AMP.
What's the networking mechanism?
Networking mechanism for what?
For like the containers, managing the containers across, for example.
So
these different.
So this I guess relates back to the work we've done within Clocker as a project. So there's out-of-the-box support for both Weave and for Calico. So the Project Calico open source project, Weave works. And so you have a choice when you're actually standing up the container service as to which of those networking SDNs you want to use. That gives you the networking at the application level that allows you to do these very rich blueprints and handle things like React, which, because it's built on Erlang, has a very rich concept of what a network should be and what it should provide. So in that sense, we are ensuring that existing platforms, and again, React is a great example of that, will run in the new world of Clocker and containers, as well as giving people, the ability to start with cloud native applications and play with those. And I think the other thing and this came out, this is a theme, if you're looking for themes from InterConnect itself, one of the things that we're definitely seeing is as people move from looking at technology and look more at the business and how they're going to actually exploit it and get value out of it, then integration becomes a huge part of this equation. And so the work we've done around the Cloud Foundry Brooklyn Bridge, which we've packaged as the Cloudsoft Service Broker, is a great example of how if I'm using Bluemix, or if I'm using Pivotal, if I'm using Staccato, or I'm just using plain vanilla Cloud Foundry, it's far more valuable to me as a business if I can then tie that back into my existing services, my data services, my systems of record, as well as reach in and actually have us stand up new services. So that integration play is really important. Now, integration for a while sort of went out of fashion. I think the more business gets into the utilizing and exploiting cloud, the more this is going to become a really, really important issue. And probably it's important, to be honest, as us talking about hybrid or multi-cloud, I mean, that makes it sound like it's something objectified out there. No, you want to actually tie all these things together.
Yes, I was going to ask you, Scott. Maybe you could help us for people who are not familiar, understand Apache Brooklyn and how it relates to Clocker and the rest of the story here that we're talking about.
Yeah, I think the rest of the story sort of gives the foundation for why these things exist. I think with cloud and containers and with the flexibility that you get from SDN options like Calico, we're really moving towards in cloud fungible architecture where service objects and blueprints are deliverable anywhere you need them and at the drop of a hat. Why we have Brooklyn and why we have Clocker beneath that is the complexity generated by a fully fungible environment, and just by layering SDNs alone needs a different management framework. So Brooklyn is built on autonomic computing, which in essence you publish sensors from your application and create effectors and write policies. Policies take the sensor information, activate the effectors, and they manage the application for you. So you move a lot of the complexity into the software layer, treating your operational environment as code.
So sensors, effectors, and policies. So
Yes.
what is a sensor then?
So a sensor is really just monitoring data. So requests per second could be a sensor. Cost of a compute minute in an API could be a sensor. Your policy could be, I need my service object or application to run in the most cost-effective place possible. So
What is the effector then?
The effector is the action that you take against the application or against the infrastructure.
You had recently published a blog post on the new Stack website. You had asserted it was called Managing the New Complexity, and you had asserted that it's these policies, that's the way to manage these systems now going forward.
The policy-based management, de facto, we've always lived in a policy-based management world. We've just affected those policies through manual procedures or a bag full of scripts or a bag full of ancillary tools that you attach onto the edge of your enterprise.
Or simply restrictions.
Simply restrictions, exactly.
Yeah.
And all these things make it very hard to play and explore and to take advantage of a fungible environment.
And you wanted to activate an action, a workflow, in a service lifecycle, and that's a piece of the pie that a lot of people are not addressing right now, unless you go to a very heavy framework that does ITSM. That's a whole other animal. Mm-hmm. But you want to be able to take those policies to activate workflows in the service lifecycle, and that's what the combination here. We're adding a lot of value in that area.
So it seems like in many respects what we're talking about as well is like an end-to-end pipeline in many ways, isn't it? Where like you're automating the distribution of the containers, you're automating the policy, you're automating all
role-based
the sensors.
access control, sensor management. Yeah,
Mm-hmm.
It's a very agile control plane for the target environment and for the application.
So this reminds me of what we hear from companies like Apsera, for example,
Mm-hmm.
and they do. How is this similar? How is this different?
We share common cause with Derek and Apsera around a lot of the concepts. The execution is different. I would obviously have to say we chose a particular path around open source and open standards, and in our world that's very important. I would never try to second guess Derek. I think he's super guy. He took a particular point of view, and coming, I guess, from his experience with Cloud Foundry and so on, he felt it had to be a strongly curated experience. We're probably, I would say, at towards the other end of the spectrum, in that we want it to be a very flexible control plane into which you can push policy. But we're essentially saying, not we'll take on all comers, but that we will support Tosca, we will support Compose, we will support, and in fact have built a lot of our core DSL on the Oasis Camp specification. But the idea that that one of those is going to win out, we don't see happening. And so think of us as really the open source, open standards approach to creating a control plane that, by the way, isn't always about applications. We have a very big deal in the UK with British Telecom, which is all around managing or controlling your fiber optic network. How can we do that? Well, because again, there are sensors telling us information about the state of that network, and there are effectors, in this case API calls that we make into controllers of the network that will provision circuits and so forth and so on. So that same, we're talking, and so pictures are somewhat hard to come by, but there's a great whiteboarding session that Scott did with me where he said, essentially that loop, that management loop has always existed, but it, generally speaking, involved people and a whole bunch of processes around ITSM and so on. So what we're doing is we're squashing that loop, we're forcing that loop down into the control plane and saying, now it is closed loop. Now we've actually embedded that logic in the control plane. So the control plane becomes a very rich way of actually not just dealing with sensors and effectors, but ultimately the policies themselves.
So perhaps it would be helpful to understand for the general audience who's listening to this, the concept behind control planes. It's one of those terms that we hear more about these days. We also hear about data planes, right? Mm-hmm. And there's a relativity here to controllers, which has a different context. Scott, can you help us maybe help understand the differences, and maybe then you could give your perspective on controllers?
For sure.
Sure. I think in the control plane, it's just another convenient level of abstraction to talk about where logic ends up being placed. And so in the model in my mind, Duncan said it quite nicely, it is the control plane is the pipe through which this loop passes, through which the behavior of your application, the behavior of your infrastructure is affected, filtered through your policies. And it's really nothing more, in my mind, than a convenient abstraction to collect the policy and control behavior.
Yeah, I would add to that you don't want to add complexity when you're bringing cloud management into an enterprise or public cloud environment. You want to reduce the complexity. I've heard that in the beginning. So our take on that is you have a black box, which we call the cloud automation engine, for example. Think of encapsulated orchestration. All the workflows that are required to run this as a fully managed service. The resource can be Cloudsoft AMP, bring up a container. It can be a soft layer environment. It can be a blue box cloud. It can be Amazon or VMware. Doesn't matter. You want to reduce the complexity by saying all the workflows that are required to run this as a fully managed service, policy based, are already there, and you set those into motion via settings in the application itself. You pre-configure everything so the workflows happen automatically. You don't want to bring, like I say, you don't want to add complexity into an already complex enterprise management environment. You want to remove that complexity. So we call our orchestration in the cloud controller is encapsulated orchestration.
Now let's take a quick break before we get back to the second half of the show. Cloudsoft is the sponsor for this week's episode of the New Stack Analysts. Cloudsoft makes application deployment possible across multiple clouds with their open platform based on Apache Brooklyn. With Brooklyn, you can create an application blueprint and deploy it across a public or a private cloud. This gives you a number of things. It can simplify the modeling of those applications. It makes it easier to deploy. It makes it easier to manage these applications. It allows you to do migration. You can accelerate the development of cloud-first applications. And it also includes the thinking that you need to have about policy. So you can deliver policy-based applications with that elasticity and scalability and portability that you need. Try it today at cloudsoftcorp.com. That's cloudsoftcorp.com. cloudsoftcorp.com. Now let's get back to the show. So this leads to all kinds of interesting questions about how does this affect the ways that we think about technology stacks overall. And for example, I've had conversations with the folks from Rancher Labs and who talk about similar types of topics, right? But there's like some stark differences here. That, for instance, introducing a new kind of networking capability that you have with Weave or a Project Calico. Even load balancers. Load balancers have a different role here. How do customers manage this, or is this something then that this partnership offers?
So, if we think about Rancher Labs for a minute, so Sheng and Shannon created what became CloudStack, and so they've taken everything they learned from that, and this is always a good business model, by the way. They've taken what they learned from that, the things that worked, things that didn't, and they said, right, we want to apply that to the world of containers. And so, if you want, you can view them as taking this is a V2 or maybe it's a VN, but it's it's a tremendous story around. Not dissimilar idea around providing a private container service. That's the way that they're marketing what they do. But if you actually scratch below the surface, there are many similarities. So what we've done, if you like, in partnership with InContinuum is come up with a similar concept, but really aimed at customers that today have been primarily focused on infrastructure, and who we would really love to drag kicking and screaming out of the world of infrastructure and out of the weeds into the world of applications and application containers, et cetera, et cetera. So I think we've come at this problem from a different, perhaps, point of view, but both Rancher Labs and ourselves in conjunction with InContinuum are essentially looking at solving, in many ways, the same problem. The approach is different, for sure, but in essence, if we're talking about taking complexity out, or at least recognizing complexity, and therefore, it's that the known knowns, the known unknowns, and the unknown unknowns. Well, I'm not sure I really have much to say about the unknown unknowns, but there's a that middle area, that grey area is an area where I think ourselves, Rancher Labs, other companies can all play.
You won't know until you know the unknown.
Well, yeah, given that I'm an observer of what is a very, I'd say, bizarre theatre called the presidential, or not even the elections, the primaries, where it's not just it's baffling rather than known or unknown. Just to come back to this control plane briefly, and Scott talked about autonomics and autonomic computing. We have an autonomous nervous system, right? And it's quite a good analogy, and this is really, the whole autonomic computing idea came out of looking at the way the autonomic nervous system works, and that's there to govern, some pretty essential things about the way our bodies function, our heart rate, our breathing, our core temperature, and so on. And could you imagine an environment like that where it wasn't closed loop, and where every time I wanted to take a breath, I'd have to raise a trouble ticket, and then some homunculus, would then, take a breath for me, and I'd be spending my entire time worrying myself sick about where the next breath was coming from, where the next heartbeat was coming from. It's a piece of nonsense, right? So we think the same is true of a lot of what people do today in management, that they really should not be doing it. People should not be in that loop. It should be a closed loop. It should be, essentially capture the management best practices. So talk to the practitioners, capture their best practices, then, exactly as Scott said, codify that, capture it as code. In the old days, we used to talk about runbook automation, data center automation. These terms, are essentially, we've taken that and we've said, let's, bring those up to date.
I would add to that, right, spot on, Duncan. I would add to that two things. Number one, to use a cliche, set it and forget it. Duncan said, take the complexity out. Once you set it and forget it, it should run by itself. You don't have to think about taking your next breath. Mm-hmm. But the second thing is be non-intrusive. Why should you sit in your control plane should not be intrusive into the service that's running, which in our partnership, we're focusing on the application, right? Mm-hmm. That should be running non-intrusively. If the control plane dies, the application should still be running where it's running. Mm-hmm. And it will run with our product. If you take not the application, or you take the container, you take the VM, doesn't matter what that service object is. If it's running, if the control plane disappears, it's still going to run because it's running on a source somewhere, a resource.
So could autonomous computing be used for disaster recovery?
Absolutely. I mean, it's a great use case. So what am I looking for? I'm looking for anomalies. Well, a classic anomaly would be a a problem, fault in the network. And I mean, this is a nuanced topic, right? So there's high availability, there's disaster recovery, there's business continuity. They're all subtly different. We're not going to solve the business continuity problem on our own, but I think, the more one can codify. I mean, here's the dirty little secret, right? I worked in financial services for years. We had a big document that said how we were going to deal with disaster, and we were supposed to test this every so often. Well, we never really tested it because people were terrified of what might happen if we tried to actually run this. So we'd run small parts of it and test them. But the idea of throwing the switch and cutting over for a long time was very, very difficult. Automation started to sort of, when I was still involved, we started to get a grip on that, a handle on that problem through data center automation and runbook automation, through really being able to do the same thing predictably time and time again. And that's the key here. So same sensor, sort of set of sensor events occur, the same action is taken. You get that consistency.
There's a big difference between recovery and responding to an external event and manipulating your application to bring it back to health. There's a big difference between that and simply describing how application should behave properly and letting the system discover and create the proper working environment for it through policies. You have multiple endpoints and you need certain amount of capacity. If one of those endpoints goes away, it should nearly be a non-event. The application should just continue to run and the system underneath it should just provision the resources that it needs to run. That's not responding to a disaster, that's just simply operating the application.
So circling back, then, this is the context of Apache Brooklyn and Clocker.
Exactly.
Yeah, and actually probably first and foremost Brooklyn, because you can think of Clocker as really an exemplar of what you can do and the richness of what's possible with Apache Brooklyn under the hood. So the core fundamental control plane, the way it's implemented, all of that is done through Apache Brooklyn, and so we build on that, and that is what we now call, thanks to Scott's sort of guidance, unpacking what we're doing, looking at it, putting it back together. That's the foundation. So Brooklyn is the foundation. Then there are these pillars: the Cloud Foundry, Brooklyn Bridge, Clocker, and of course a catalog of other commercial and open source stacks. By the way, we use that term too. So, the Basho data platform being a great example.
I'm glad I'm not the only one.
No, I think you hit on something there.
So how much work is it to set up all the rules that are needed to put this in action? Is there a lot of? Do you have to think through all the possible combinations?
It's not an infinite solution space that you've got to search through. You start by, you could make it that if you want. If we take a case in point, and I'll mention Basho one more time, React is well documented. It comes in different flavors. We've built blueprints that allow you to deploy those different flavors. Where we've not understood something, we've talked to the practitioners, we've talked to the field engineers or the core engineering team at Basho to say, can you explain this to us? Right, fine, now we get it. Now we can code it up. So it is a process of collaboration. So, to do it from first principles would be hard. You'd have to become a domain expert in pretty much everything you touch. And that's not our skill set. Our skill set is we know how to build blueprints, we know the right questions to ask, but it ends up being a dialogue with whomever we're working with. And that could be an open source project or it could be another company. And I think this is an important point to take away, that over time, the control plane is valuable, but what's really valuable is what you do with it, and that, in a sense, you build up that portfolio of blueprints.
Policies are composable. It builds over time, and it's iterative in the same way that code is iterative, in that you, as your application lives and breathes, you discover the promises that you want for it to make to your customers, and then you find a way to make sure that those promises come true.
So what's the technical architecture underneath all of this? Can you talk about that at all? I mean, we talk about Brooklyn and what it does, and we talk about, how it integrates with the cloud controller. I mean, can you give us an understanding of what the stack looks like?
So it's Java. There's a layer sort of if we put the target environments at the bottom, so various cloud, AWS or Blue Box or a container environment. At the bottom is the cloud layer. The next layer up is an interface layer where we use things like JClouds, drivers we've written ourselves, Clocker, in order to instantiate and interact with the target environments. Just above that is sort of the meat of the architecture, which is the autonomics engine, which is Brooklyn at the core.
What is that engine then? What is it exactly?
Let me answer that if I may. Essentially, there is, because we're talking about sensors, we're talking about events. There is a message bus.
Okay.
So at the heart of, if you unpack it that next layer down, then that message bus is essentially where the sensor events are posted. Of course, we've done this very efficiently, so we understand the scope. So it's not that every event is published everywhere, which would be a network storm,
right. But
instead you understand the scope. So this sensor event is being consumed by this autonomic manager, which manages a cluster of in this case, let's say Tomcat servers. And so that nicely scopes the sort of event horizon, so to speak, and that's not a pun. Or maybe it is. And so that's on the one hand, so that's driving the change, but then you also implement the policies that then clearly react to those events, analyze those events. In classic autonomic terms, you monitor, analyze, plan, and then execute. And so the policy is really that analysis and that planning. And so rather than that being some philosopher humming and hawing over what to do next, it's already been encoded. Now, policies themselves, and this is the beauty of autonomics, are themselves managed elements. That means they have sensor and effector interfaces. What is their sensor interface? Well, the sensor interface will be the policy reporting out on how it thinks it's doing, and the effector interface will be our way of interacting with it and changing or fine-tuning it. So if we're unhappy with, maybe it's sailing too close to the wind, we think that the SLA that it believes it's maintaining is a little bit close to the edge, then let's ratchet back that policy. Let's be less aggressive.
We need a little bit more wind in that gym, kind of.
Yeah, and so I wouldn't want to say you have policies guarding policies all the way down, but you could do that, but it would be a little strange. But you certainly want to be able to have at least two levels of observation. And incidentally, that's something which, if you study the architecture of Mesos, those guys grok that you need scheduling, and in their case it really is a scheduler down at the sort of first level, looking at the raw resources. But then you introduce second level scheduling, which is really where you understand, what am I dealing with? Is it Marathon? Is it, in which case it's containers? But there is knowledge now of a domain that you're dealing with, and so you have that negotiation between the two. So I think we see policies operating very much the same way. It's not a hit and hope. It's something where you want to observe that over time, the behavior you expect, many times emergent behavior is the behavior you actually get, and if not, how am I going to change that? What do I need to actually fine tune? So, and I think there is an art to this. I mean, if that hasn't come out in the conversation, let's put it out there that there's a skill in the same way that programming is a skill, developing blueprints is a skill, understanding the right policies and how to apply them is very much a skill. So when people talk about programming the infrastructure, in a sense, these blueprints are doing exactly that. Why? Because they want to deliver an application, not because they think it's a fun thing to do. Make sense?
Yeah. So we were talking about the meat of it, right? And then we're moving up from there. What do we see?
Yeah. So the event and message bus and the autonomics engine. Really, on top of that is the interface layer where we express the model, monitor, manage, all of which is API driven. So you not only have a GUI interface for designing your application blueprint, you also have a CLI where you can work programmatically with the API to generate blueprints in a programmatic fashion. The other two components, the monitor and the manage, are where we surface to an end user the things that are happening in the inside of the engine, and optional ability to interact with it and to adjust it at that level on the fly.
From our perspective, it's, I don't want to go into all the buzzwords, but it's purely a simple straight-ahead server architecture for our platform, and we communicate with Cloudsoft AMP over a standard REST API, and we've both customized the APIs to support the specific features and functions that we want to be able to offer to our joint customer base. So I'm not going to throw out a whole bunch of buzzwords, but it's a pretty straight-ahead server architecture, and our application is self-built. It's not on open source stuff. It's proprietary, but it's on open standards.
So one of the interesting things about what Phil just said there is that, blueprints that we already have can surface as items in their service catalog. And so there's a very nice synergy here where, and we've done the same thing with ServiceNow, for example, where, because we want the addition of the sort of role-based access control, et cetera, then we're happy for, them to be in your service catalog, and then obviously you call back to us,
Yep.
Say, right, have at it, JFDI, and then we go, fine, we'll do it. And then we, of course, then call your API to actually negotiate for resources in order to actually deliver it. So that's a kind of nice model, I think.
Right, and to add on to that, if a new service is defined in the Cloudsoft environment, we're polling that, and we read in new services that are available. They can be put into the Cloud Administrator Service Catalog, and through our system, he can define which service users in his cloud have access to those services, or have bespoke access to a certain group of those services. Mm-hmm. So it's truly it's an interactive process, and we are talking to each other in real time. So if someone does add a service, it can appear in the service catalog in no time.
So you think about multi-clouds, right? Environments. There's also the need for multi-platform environments, right? So like the need to have better APIs. So if you can think about using Docker Swarm, right, or versus Kubernetes versus Mesos. How do you guys approach that philosophy?
We're asked to support pretty much all of the above. So we see our job in the same way that we recognize, or we've come to recognize, that if somebody is invested in a whole bunch of Tosca blueprints, we need to be able to consume those. Or likewise, if somebody wants to deploy to a plain vanilla Docker environment, they can do that. We've recently added Mesos support, so that essentially, if somebody wants us to target a Mesos environment, we can do that. In some cases, we're very light touch. So, working with the Basho team on some new work they're doing around Mesos. At times, all we're doing is then calling out to DCOS, which is the commercial data center operating system, which is the packaging of Apache Mesos by Mesosphere. And so, we'll back off and we'll delegate to the Mesos guys where it's appropriate. So, I'm not going to sit here and say who's going to be the winners and who are going to be the losers. I'm just here to support, what an enterprise has asked me to look at. And so,
right,
of course,
exactly.
I have an opinion, but and I won't be shy about saying where I think it's appropriate to use these different platforms. But
right.
But they're all relevant.
And we take the exact same strategy on what I call the cloud plumbing, the multi-cloud. We don't dictate what our customers use. If they want to use VMware or Red Hat or SoftLayer or Azure or Amazon, any of the public clouds or hypervisors, we support them all, OpenStack. So we don't dictate what they use. We support them all, and we can bring up a container on any of those platforms. Mm-hmm. We share the same philosophy on how that has to happen. Cloudsoft on the application tier and us on the cloud plumbing tier, to lack of a better word. Yeah.
So it's a good way of thinking about it. It's also, by the way, when we talk about deploy, monitor, manage, and you talk about it,
create, deploy, manage.
Yeah, so create, deploy, manage. It's very much, we're in simpatico, well, we were until you corrected me. Now we're in violent disagreement.
It's going to get ugly from here, that's for sure.
As usual.
Is there a standard or a spec for defining patterns? If I'm running an open source project, can I fill out these patterns myself, or what's the...
Absolutely. I alluded to this before. We were one of the founder members of the Oasis camp specification. So Alex, our CTO, has been on the technical committee since day one.
What's the specification here?
Camp.
Okay.
Oasis being the organization.
Sure, yeah.
Oasis also has Tosca, which sometimes is positioned as competitive. We, I think, have finally driven home the message that they're not competitive. They are, they're two sides of a cube. They're two different ways of looking at the same thing. Fundamentally, Tosca is very good at the nitty-gritty. It's a bottom-up approach. It tends to be favored by infrastructure folks as a result, whereas Camp is very much top-down, more about specifying the intent, what you want to have happen, but don't go prescriptive on me and tell me exactly how to do it. Don't tell me my job, right? You tell me my job, you're not my friend. But tell me what you want, and I'll do my best to deliver it. And so, that notion of intention informed the way in which we approach the virtual networking through Calico. I can literally say, I would like a virtual network, and I'll call it foo. And now I have foo, and I don't care, what the CEDAR is or any of this other stuff, and I can now reference foo within my application blueprint. I can say this cluster is attached to the foo network. I can also have bar, and I can have, and so on and so forth. And if I want to be a bit more, if I have reason to want to specify, public IPs, or I'm trying to, model an existing application which has some, unfortunately, hardwired assumptions about networking, God forbid, does happen, then I may actually, provide some hints that, in this instance, rather than you decide, I'm going to give you some guidance as to what the CEDAR should be, so what the IP address space should be, and so on. But the idea is only do that when you absolutely have to. You could call it being lazy. I call it being intent-based.
Otherwise, it's really foobar.
Well, obviously, I'm sure some people listening to this will know what the hell I'm talking about, and will probably also know what snafu is.
This has been a great discussion, you guys. Thank you very much for taking some time to talk with us.
Thanks for having us.
Yeah, there's a lot of new concepts here. There's a lot more to explore, so I'm sure we'll be back again soon talking about these topics. So thanks again, and let's keep in touch.
My pleasure. Thanks.
Look forward to it. Cheers.
Cloudsoft is the sponsor for this week's episode of the New Stack Analysts. Cloudsoft makes application deployment possible across multiple cloud platforms with their open platform based on Apache Brooklyn. With Brooklyn, you can create an application blueprint and deploy it across a public or a private cloud. Brooklyn simplifies the modeling, deployment, and management of applications, enabling application migration, accelerating the development of cloud-first applications, and delivering policy-based application elasticity, scalability, and portability. Try it today at cloudsoftcorp.com. That's cloudsoftcorp.com. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again. Hope to see you again for the New Stack Analyst podcast. Bye-bye.